All right, I'm just going to do a review for Unit 8, and I'm going to go through the review that either you received in class or you can print it on the website. So starting on the multiple choice side, which is all factoring, and there's really three different types of factoring. Greatest common factor, factoring when A is equal to 1, and factoring when A is not equal to 1. So you kind of have to be able to tell which type you're looking at as you go through. So on number 1, it looks like my A is equal to 1 because there's no number in front of this X. So I'm going to use the A equal to 1 method, and there's all three terms, so greatest common factor by itself is not going to work. So I'm going to start by finding my A times C, which is 1 times a negative 14, which is negative 14, and B is 5. So I need two numbers that multiply to negative 14 and add to 5. So 1 and 14 isn't going to add to 5, but 2 and 7 I could get to 5, but 1 needs to be negative. So if I have a negative 2 plus 7, that's 5. Negative 2 times 7, that's a negative 14. Now here's the thing that often throws people off is sometimes they'll just think this is their answer, negative 2 and 7. But that's what goes into your factored form, x minus 2 and x plus 7. To get your answer, you've got to set each of those equal to 0. So gotta do my minus sign. X minus 2 equal to 0 and x plus 7 equal to 0. So if I add 2 to both sides, x equals 2. Subtract 7 from both sides, x equals negative 7. So my solution is x equals 2 and negative 7, which is D. And oftentimes, both of these will be options, so you need to make sure that you put it in factored form first and then get your solution so you don't miss it just because of a positive negative sign issue. Number 2 is the exact same type of problem, so I'm going to let you try it, but I'll tell you right now that your answer is A. So try it first and make sure you can get A as your answer. Number 3 is a new type of factoring. It only has 2 terms, which is a clue to me that it's probably going to be solved using greatest common factor. So if I look at these, I have a 1p squared and a 4. So 1 and 4, the only thing that goes into both of them is 1, but they both have a p. So I can take out a p, and then p squared, if I take out a p, I have 1p left. Negative 4p, take out a p, I just have negative 4. So this is factored, but I now need to set these each equal to 0. So I'm going to set p equal to 0 and p minus 4 equal to 0. And this one's already good, so one of my solutions is 0. This one I add 4 to both sides, and p equals 4. So my solutions are 0 and 4, which is C. But again, look at option A is the exact same, except my 4 is negative, so you've got to be really careful about that and make sure that you're paying close attention to your positive and negative signs. Number 4 is exactly like numbers 1 and 2, so I'm going to let you try that one as well. But again, I'll give you the answer so you can check yourself. So try it, and you should get D as your answer. All right, number 5 looks a little bit different. So one thing that I should have been better about talking about up above is before you start factoring a problem, you should always see if there's a greatest common factor you can factor out. So right here I have 2, 18, and 16, and 2 goes into all of those. So then I'm left with n squared plus 9n plus 8. And this quadratic I have in parentheses is exactly like numbers 1, 2, and 4. So I can find my A times C, which is 1 times 8, or 8, and B is 9. So two numbers that multiply to 8 and add to 9 are 8 and 1. So this factors to 2, stays out front, and then I have an n plus 8 and an n plus 1. To solve, the 2 doesn't affect my solution. I just set each of these equal to 0. So I'll set n plus 8 equal to 0 and n plus 1 equal to 0. Subtract 8 from both sides, and n equals negative 8. Subtract 1 from both sides, and n equals negative 1. So negative 1 and negative 8 are my solution. Number 6 is very similar to number 4, but I'll go ahead and do it with you. So this time I have 3 and a 6, and I can pull something out of both of those, which is a 3, and they both have an n. And then I'm left with n minus 2. So I've got to set both of these factors to 0. So I'm going to set 3n equal to 0 and n minus 2 equal to 0. This one people are usually pretty good about. They can add 2 to both sides, and n equals 2. But this side, to get rid of that 3, we're going to divide by 3. So 0 divided by 3 is 0. So my solution is 2 and 0. A lot of times people miss that 0, so make sure you don't make that mistake. And again, positive and negative signs, make sure you know which you're dealing with. And number 7 is our last type of factoring. So this time my a is not equal to 1, and there's not a greatest common factor I can pull out. So I'm going to start the same way, find my a times c, which is 2 times 15, or 30, and my b, which is negative 13. So two numbers that multiply to 30, but add to negative 13 are negative 10 and negative 3. So now what I'm going to do with these two numbers is use them to replace this middle term. So I have 2r squared, and instead of minus 13r, I have minus 10r minus 3r plus 15. And then I can factor by grouping. So on this side, I can factor out a 2r, and I'm left with r minus 5. This side I can factor out a negative 3 because I want my r to be positive. And then 15 divided by a negative 3 is a negative 5. And then my parentheses are the same, so I have r minus 5 and 2r minus 3. So now I just need my solution, which I get by setting each of those equal to 0. So this one I can add 5 to both sides, and r equals 5. If I add 3 to both sides, 2r is equal to 3. And then divide by 2, and r is equal to 3 over 2. So I have 3 over 2 and 5, which is option D. And then I want to let you try number 8 because it's just like number 7, but we'll come peek at the answer. So number 8, you should get C as your answer. So try number 8, then hopefully you get C. And we're going to move on to the free response side of your review, which deals with our systems of equations and our creating equations. So I'm going to start by just showing you one system of equations since they're all done in the exact same method, and then I'm going to let you do the others. So if y is equal to x squared minus 5x plus 7, and y is equal to 2x minus 3, then these two things have to be equal to each other. So I have x squared minus 5x plus 7, and that's got to equal 2x minus 3. And in order to solve this, I need everything on the same side of the equal sign. So I'm going to subtract 2x and add 3, subtract 2x and add 3, so that these cancel, and I have x squared, negative 5x minus 2x is a negative 7x, and 7 plus 3 is 10, and that's set equal to 0. So now I can factor this just like we were doing on the front page. So I have a times c is 1 times 10, which is 10, and b is a negative 7. So two numbers that multiply to 10 and add to negative 7 are negative 5 and negative 2. So again, I'm going to make sure I put that in my factored form. Those aren't what x equals, that's what helps me get this factored. Then when I set each of these equal to 0, x equals a positive 5 and a positive 2. In order to figure out what y equals, I can just plug these in for x in my equation. So if I plug the 5 in to start, 2 times 5 is 10, 10 minus 3 is 7, so y is equal to 7. And then if I plug in a 2, 2 times 2 is 4, 4 minus 3 is 1, so y is equal to 1. And the cool thing about that is I could also have plugged these into the top equation and got the same thing. So 5 squared is 25. 5 times 5 is 25, so 25 minus 25 is 0. 0 plus 7 is 7, which is what I got with the other equation. And if I plug a 2 in, 2 squared is 4, minus 5 times 2 is 10, plus 7. 4 minus 10 is a negative 6. Negative 6 plus 7 is 1. So you get the same answer either way. So I'm going to go ahead and let you do numbers 2, 3, and 4 to make sure that you have practice doing them. And if I have time, I will come back and show you the answers. But for now, we're going to move on. So numbers 5 and 6 have to do with going between phrases and expressions. So this starts with sum. And I know that sum comes from addition. So I'm going to be adding something. So it's the sum of 6 times a number n. So I have 6 times n and 7. So I have 6n plus 7. So then I'm going to use this same pattern in order to write number 6 as a phrase. So I'm going to start by looking at the main thing that's happening, which is this plus right here. So I'm going to start with the sum. And it's the sum of the 15 and the 7 over x. So I'm going to start with the sum of 15 and 7. This is 7 divided by x, and division, the solution to a division problem is termed the quotient. So the sum of 15 and the quotient of 7 and a number that in this case we called x. So the big thing that I would advise you to remember is that you're going to start your phrase with whatever the main thing that's happening is. So it's going to start with the sum. So even if this was written the other way around, I would still start with the sum and then of the quotient of 7 and x and 15. Numbers 7 and 8 are the famous story problems we all love so much. So we're going to start with number 7, and each one needs an equation, and then we're going to solve that equation. So a plant is currently 13 centimeters tall. So I'm going to start with 13. And then it grows 0.7 centimeters a day. So plus 0.7, and then I've got to keep reading to see if I know how many days there are. How many days until the plant will be 17 centimeters high? Okay, so how many days is my variable? That's what it's asking. That's what I don't know. So if it grows 0.7 centimeters per day, it's going to be 0.7 times however many days there are, which I'm not sure of yet. And we want to know how many days it will take until the plant is 17 centimeters high. So now I can just solve this for x. So this is my equation. To get my solution, I'm just going to solve this for x. So I'm going to minus 13 from both sides. So these cancel, and I get 0.7x equals 17 minus 13, which is 14. And then I can divide by 0.7 to get x by itself. So if it were me, I would pull out a calculator, and 14 divided by 0.7 is equal to 20. So my x equals 20. So my question was how many days, and that's what x represents. So if x is 20, then my solution is it will take 20 days. The last one, I start with the length of a photograph. So I'm going to draw my photograph. The length of the photograph is 2 centimeters less than 2 times the width. Okay, I don't even know what the width is yet, so I'm just going to call that W. And then the length of the photograph is 2 centimeters less, so I'm going to take 2 away, then 2 times the width. And then the area is 50 centimeters. So I've got to do W times 2W minus 2 is equal to 50. So I'm going to kind of speed this process up, but you're going to multiply these things together and get everything on the same side, which leaves you with 2W squared minus 2W minus 50, which you can then factor and solve. So once you factor out your 2, oh, this is just 1W, then you can factor and solve this, and then you'll know what your width